This is Mr. Martin. This video is for geometry. We are talking about section 9.1. This is part B. We're going to be talking about the Pythagorean Theorem today. So let's take a look at this right triangle. We're going to label the triangle and identify the legs and the hypotenuse. So let's call this triangle ABC. And we're going to make a list of, so here's our sides. We're going to make a list here. We're going to have legs, and we're going to have the hypotenuse. So in a right triangle, we're going to have a right angle here in the corner. There's our right angle. And then the two sides of the triangle that make that right angle are going to be called the legs. So in this case, we have AB and we have BC. Then, again, here's our right angle. If we go across from the right angle, since the right angle is the largest angle in the triangle, the hypotenuse is going to be the longest side in the triangle. So the hypotenuse is going to be segment AC. So, again, here's our legs. One there, and one there, and then our hypotenuse is right there across from the right angle. And it's going to be important that you can find the different sides for a right triangle. Identify those. Alright, let's move on. So let's look at one of the ways that we can show the Pythagorean theorem. So we're going to draw a triangle with legs of length 3 and 3. So I'm going to draw this right here in the middle. You probably want to draw it in a similar spot. So there's one leg of length 3. Here's another leg of length 3. And we're going to draw the hypotenuse in there. Okay, so we've drawn a triangle with legs of length 3 and 3. Create 3 squares on each side of the triangle, using each side of the triangle as one of the 4 sides. So basically we're going to use each side of our triangle to make a square. So since this side is 3 units, then I'm going to make a square that's 3 by 3 on that side. I'm going to make another square that's 3 by 3 on this side. And my last square over here is going to go, so this does go right through those points there. So it's going to go through 3 squares diagonally. So I'm going to go through 3 squares diagonally there, and 3 squares diagonally there, and then we'll connect that. So we've drawn a square on each side of our triangle. So the area of each square, find the area of each. So since this is a 3 by 3, we could actually count the squares too. It's going to be 9 square units. Alright, and this one down here, the area is also going to be 9 square units. And then this one over here, each one of these little diagonal pieces here is going to be the square root of 2. So we won't really go into how to get that right now. But this whole length here is going to be 3 square root of 2. So that means that this here is going to be 3 square root of 2. And then to find the area, we're going to multiply those. So 3 square root of 2 times 3 square root of 2. So 3 times 3 is 9. And square root of 2 times square root of 2 is 2. So that's going to be the 18. So the area of this one is equal to 18 square units. Alright, so if we look here, this area we can find by taking the length of this side and squaring it. So 3 squared is 9. Okay, so that's 3 squared. And the area of this one is also going to be 3 squared, which is 9. And the area of this one here was 3 square root of 2 squared. So if we notice, 9 plus 9 gives us 18. So another way that we could say this, and this would be true for any right triangle, is the sum, so sum we're adding, of the areas of the two small triangles equals the area of the large triangle. Okay, and we're going to rephrase this in just a minute in the box below using the sides of the triangle. So the sum of the areas of the two small triangles equals the area of the large triangle. So the 9 here and the 9 here equal the 18 there. So the way that we're going to state this in the Pythagorean Theorem, which you may have heard before, in a right triangle, the sum, remember that means adding, of the squares, so we're going to do squaring it is just multiplying it by itself, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. Alright, so if I have a triangle, a right triangle, with sides A and B and C, what this is saying is so the sum of the squares of the sides, so here's the square of one side, here's the square of the other side, the two legs, the sum of those is going to equal the square of the hypotenuse. Okay, A squared plus B squared equals C squared. So again, hopefully this is a formula that you've seen before, or a theorem you've seen before, and we're going to be using this quite a bit. So let's take a look at one quick example before I end this video. So let's look at a triangle here. And I've got a side of 3. Here's my right angle. And I don't know this side, and I know the hypotenuse is 9. Alright, so let's identify the legs. The legs are x and 3, and the hypotenuse is going to be 9. So if we're using a squared plus b squared equals c squared, the a and the b are the legs, so that's the x and the 3. So I have x squared plus 3 squared is equal to, my hypotenuse is 9 squared. So that's x squared plus 9 is equal to 81. I'll subtract 9 from both sides, so x squared is equal to 72. And we'll take the square root of both sides. Square root of x squared, square root of 72. So x is the square root of 72. So if you remember from algebra, when you take a square root of both sides like this, normally we need a positive and a negative. But since we're talking about a picture here, we really just need the positive one. Alright, now, last step, we need to check to see if square root of 72 simplifies. So I'm going to do a factor tree here. So 72 is 9 times 8, and 9 is 3 times 3. So here's prime numbers. I'll circle those. 8 is going to be 2 times 4. There's another prime. 4 is going to be 2 times 2, so 2 more primes. So square root of 72, I'm just going to pair up the numbers. So I have 2 times 2, and a 3 and a 3, and then I have 1 left over 2 here. So this becomes a 2, and this becomes a 3, and that stays the same. And our final answer is 2 times 3 is 6, root 2. There's our final answer for the length of the other leg of that triangle. Alright, so a lot of information there. Go on to watch the next videos with some more examples, and as always, if you have questions, make sure you get those answered, and we'll see you next time.